Hello, my name is Matthew Stern. I'm going to be doing the questions with the work shown for test 3. 29 says, an unknown substance absorbs electromagnetic radiation with a wavelength of 9 kilometers. Calculate the photon energy in units of gigajoule. Okay, so we know we have the wavelength of 9 kilometers. So the first step is to turn that into meters. So 9.0 kilometers times 10 cubic meters over kilometers, units cancel. That's the conversion from meters to kilometers. That comes out to be 9.0 times 10 cubic meters. That's good because it's in scientific notation. The next step is we want to get the frequency from the wave equation, which is the speed of light over the wavelength. So speed of light we know is 3.0 times 10 to the 8 meters per second, and then divided by our wavelength, which is 9.0 times 10 cubic meters. The meters cancel, so we end up getting 0.33 times 10 to the 5th, but that's not in scientific notation, so we need to move the decimal to the right one, increasing by 1. So we got to decrease the exponent by 1. So this comes out to have a frequency of 3.3 times 10 to the 4th, 1 over seconds. So now we want to get the photon energy from Planck's equation. So that's Planck's constant times the frequency. So we know Planck's constant. That's 6.6 times 10 to the negative 34 joules times seconds, multiplied by our frequency, 3.3 times 10 to the 4th, 1 over seconds. The seconds cancel, so we're left with joules. This comes out to be 2.2 times 10 to the negative 29th. Come down here, and then we want to convert the joules to gigajoules because we wanted the answer in gigajoules. So it's 2.2 times 10 to the negative 29 joules times 1 over 10 to the 9 joules. The units cancel. That's the conversion from joules to gigajoules. You have to bring it up. So that makes the sign switch. So our final answer is 2.2 times 10 to the negative 38 gigajoules. All right, number 30. And this is the correct answer, 2.2 times 10 to the negative 38 gigajoules, and the other ones are the wrong values. Number 30, a piece of foil has a mass of 9.0 times 10 to the negative 2 grams. The foil has a length of 3.00 centimeters and a width of 2.00 centimeters. The density of the foil is 2.5 grams per centimeters cubed. Calculate the thickness in centimeters. So we know our mass, density, length, width are all given to us. We want pretty much the height, which is also can be thought of as the thickness. So using the density equation, we could solve for volume, which is mass over density. So that's 9.0 times 10 to the negative 2 grams over density 2.5 grams per centimeters cubed. The grams cancels, so we're left with the volume at 3.6 times 10 to the negative 2 centimeters cubed. So now we want to take the volume equation, length times width times height. That's the volume. And then we have that equaling the length at 3.00 centimeters, the width at 2.00 centimeters times h. So we want to isolate for h. So doing that, that's multiplied together to 6, divide 3.6 times 10 to the negative 2 divided by 6. You end up getting 0.6 times 10 to the negative 2. But that's not in scientific notation, so move it to the right. The decimal, that increases the number by 1. So we got to decrease the exponent by 1. So we end up getting 6.0 times 10 to the negative cubed centimeters. And that's our thickness or height. So that's the correct answer right there. All these four are the wrong values. 31. A piece of solid carbon weighing 6.0 grams is burned until no residue remains. Assume the only product is carbon dioxide. how many grams of carbon dioxide are produced? So we have 6.0 grams carbon times 44 grams carbon dioxide over 12 grams carbon. Units cancel. We get, this is given in the problem, this is given in the box. So we get, this ends up coming out to 22 grams of carbon dioxide. Is correct answer. These are wrong, the wrong values. 32. A ULCC is a very large ship designed to carry oil. It can carry up to 2.88 times 10 squared megagrams of crude oil. Convert the unit to milligrams. We have 2.88 times 10 squared megagrams times 10 to the 6 grams over megagrams. The units cancel. That's the conversion. Times 1 over 10 to the negative 3 grams. That's the conversion from grams to milligrams. Bring up the 10 to the negative 3. So the sign flips. So this is what it comes out to be. 2.88 times 10 squared times 10 to the 6 times 10 cubed. That's 2.88 times 10 to the 11th milligrams. And then this is the correct answer, and these are the wrong values. And the last one, a piece of solid sulfur weighing 9 grams is burned until no residue remains. Assume the only product is SO2 gas. How many grams of sulfur dioxide are produced? So we're given 9.0 grams of sulfur times 40 times 64 times 64 grams of SO2 over 32 grams of S. We get that from the table. The units cancel, so we're left with grams of SO2 being 18. 18 is the correct answer, and these are the wrong values.